day! It's so hot in here. Hello everyone. I still need to start TTS, I'm sorry. I'm late. I took a nap because a lot of work and it will be a long night. Wait a second. Oops. Okay. I'm hoping TTS will work today. All right.
bitluni desktop version 4.2.0 starting.
Here. All right. Hello everyone. Hello Sonic. Hello TMK. Hello Yombo. Hey Jordi. Hey Ray. Hey Kaspar. Hey Dutch. Who did I miss? For once I won't have watched the beginning of the stream with 2 times speed. So how was your day? How was your day? Wait, let me read back what I missed. Oh. Hello Nicola. So today we'll be doing different stuff. And I don't know where my hot glue gun is. It would be nice to have that because we played around with, hey David, played around with an Hall effect sensor last time and I got stuff from China, the current sensor, DC current sensor, and yeah, do we have, where's the one without, here. I got inspired trying to make one myself. So there is a board with an amplifier. Okay, we can open that. And there is one without the amplifier. It's just a Hall effect sensor and what looks like does TTS work? Here we go. This is how it looks like. TTS doesn't work. Wait. Here we go. Now deployment was confirmed. I will get... I get all the messages now in my ear. So that looks like a ferrite core, which is split in the center. And oh, a new curing machine. Okay. Hey Johnny. Hey Myland. You know people. You remember where we were talking about the excavator. Johnny was still reading back. How was the hangout yesterday? Oh, we played a little bit, we chatted. Well, we had like good 2 hours, and I was probably even longer there. Fun fact. Yeah, Johnny is the first excavator. Hey Christian, thank you for the sub. The first one. What there have been somehow I told one of my friend, and he even like told another friend. Now we have like $55 already for the excavator fund, which is crazy. Look at that. Oh wow, doxing the names of my friends or what? If the text is quite honest, so it's a completely selfish fundraiser. You can read it yourself. Here's the info. Don't feel pressed to act on that. I will. Oh wow, the TTS. Hype train is incoming! What? Sonic, thank you for the sub. It's a. I will fill up the remaining 99% if needed at some point, because I really would love to have one of those excavators. Oh, an ad, Myland. Oh no, Fire TV ad. Oh. I earned 1 cent from that. My chair is squeaky. Should I get some lubrication for that? What do you think? I bought like what's the oily spray thingy called? I can spray that. Anyways, so much about the fundraiser. Thank you for the hype train. And yeah, so oh wait, this is. Am I doxing my editing? Yeah, I'm still editing the video. Yeah, DW40. Yeah. I can close DaVinci Resolve. Yeah, DaVinci. The Studio Edition. That was worth the money. I mean, I bought, I think, even like 2 licenses. One for a former editor of mine, and that was for HDR goodness. Yeah, totally worth it. I hope they don't change it. If they the own company of Unix, really, yeah, Fenua. It was spontaneously. It wasn't posed. I just hop on. It's like an entryway of the hardware store in Kassel. It was just in the entryway, and we were just leaving. Bought some plants and planting stuff, and I saw that, and I was really happy to see that the China mini excavators are basically coming to Europe right now. So currently they're pricey. There is an excavator for less, I think 4,900 in another hardware store, but it doesn't come with all the accessories. Like you need like the big shovel and the flat one and whatever. So that one, and each of the accessories cost like $100. So it might be worth to checking that, and at some point it might not be like exactly that one that I buy in the end. Might be by that time that other ones are cheaper or more affordable or whatever, and I won't buy one of AliExpress or Alibaba because I just want the warranty. So I don't want to mess around and whatnot. There's the shipping, yeah, and then you get like some customs trouble, and like the customs, they don't like me, it seems. It always takes ages, and I have like to pay a lot for import taxes, and yeah. Then also like the offers on AliExpress, they tell you like, oh yeah, it's $1,000 or whatever, but that's like a prepay, and you have like to Hauptzollamt of that, yeah. So I'll be certainly buying one of a seller in Germany to have 2 years warranty, and basically, I don't know, if it's like 2K more that it costs, so be it. I have to go fund me for that. The first lubricant will be paid from the GoFundMe. Anyways, we need to crank out projects to have to earn money for a mini excavator. So I was talking about the current sensor, and I'm intrigued to test how that works. I don't know if this one. Oh, yeah, we can find out where, like, what the terminals are, but we tested the Hall effect sensor and last time, and now I have a proper breadboard for that. I will turn on the camera in a second. But what else I got? Where is it? Here. What else I got that we can test? I'm really curious about that. Fuck. Oh, okay. Yeah, the vice grips. You need to open them. I took a 10 millimeter nut. Is it 10 or is it 12? Whatever, and cut it open. Ah! Tooth removal, yeah. So I cut it open, and then we can slide in the Hall effect sensor to measure basically the magnetic field that's induced through the current that's flowing through. And I would like to have a setup, but I don't know where my my hot glue gun is. So I would do the setup, and we can then measure these magnetic nuts. Where did I put it? It has to be here. I didn't find it in my toolbox. Yeah, this is what happens when I clean up. I cleaned up my lab, by the way. I don't know if you can tell, because already put stuff everywhere. Oh well, we have to live without the glue then. Do we tape it? I don't know what we do. Okay, let me set up the camera first. So we will be able to see what's happening. Here. Hey Ray. Oh Max, hi by the way. All right. Camera, I need another lens though. Changing lenses. Or swapping. All right, now we have the wider angle view. Where is it? Okay, autofocus. That was the mega cluster, by the way. At some point, we should be able to try that as well. You remember the mega cluster? I never made it do anything, really. Okay, we need this. Then we need a load. We need our power supply, which is here, but I can put it on the table. Can I? Yes, I can put it on the table. Oh. Oh. There we go. We have some power cord. We need a cable. Some cable that can do current. I think, no, this is not good. Oh yeah. This is again open. Sorry, it takes me a while to find it. Oh! Andy, thank you for the sub. Pop. Yeah, alright, we take these cables here. Wait. Can we get, no, we can't put it through there. I would need some cable that is open on one end. I have something here. That was loud, what? Did you hear that? What was loud? And hello. The animation? You wait. Oh yeah. Then I will make it. Good that you say that, because I do it. I make it like. Wait. Why not a washer? I tried. Washers. Wait, where are they? Because stacking washers is probably better for the magnetic flow. Hey Dave. Oh, so many people today. What's going on? Is it too hot outside? Here. So I took a. Oh, I don't know. That's like a brand that you could buy. Tenma. It's too loud. It's too loud for my taste. I want a passive one. Yeah, I tried to using the saw. With like the electric saw with that focus, and you see, yeah, they bent and they got stuck in the. So I have washers. We can try like a single washer or whatever, if it fits. Ah, yeah, people are annoyed with the super glasses. What is super loud? Oh yeah, righto, yeah. Usually they all are. I hate that. Why isn't there like a at this point, like with this tech that we have available to us, why isn't there like a passively cooled device? I mean, an oscilloscope doesn't do lots, like current wise, does it? Why does it need like to? Oh, it probably needs to temperature control. All right, but then you can also use a Peltier element. I tried. I have only a small Dremel. Yes, we can do that. All right, so we'll put this in here. Then we will use a 5 volts here. Powering the breadboard. This is 5 volts here. I hope it's still 5 volts. So we can power that. And this is, yeah, we can open that a little bit and put it through there. Only half a winding, or do we try multiple windings? Okay. It's not like it's too narrow. Let me zoom in. It's too narrow to like do an uninterrupted measurement, so it's not a clamp meter. I'm wondering what happens if we cut it completely open. It's probably not that good anymore. So I will do a test another time where I cut it completely open. Took me a while. Okay, we do one loop through the nuts, and then oh wait, we put this inside of the load. This is the load. Yeah, load minus plus. Then we can, yeah, I do more, I open it more so we have a little bit more. I don't know, I have no clue. This is the only power supply that I ever bought. I wanted to buy one, passive one, but my coupon ran out and I wasn't able to buy it. Because I had like a lector of, I don't know, there was like an article about one of my projects in a lector and they gave me like a coupon for their shop, but it expired before I was able to buy the new power supply. Wait, okay. Is it like, oh yeah. Does it work? Okay. We have power on that. We should be able to power this thing. Anyone remembers what the pinout was? Center was, I don't know anymore. Oh yeah, we need the scope. We need a scope. Oh. You can use any scope. You can probably even use the multimeter to measure that. So don't be intrigued about this quite expensive one here. Wait a second. Why is this? yes, the sensor will go into the slit, and I hope that the current is induced in the nut. Why is this? Everything is entangled here. And if this works, this will be a micro video that I do, like a quick one, a mini project. Maybe even make a board for that. We can make a board for that with an amp or whatever. Yeah, all right. Okay, 1.5 watts. We get some current. Now I will do the setup here. We need a power cable. Right. Can of magic smoke? No way. Where's my? Here's the probe with the. All right. We need some wires. A flux capacitor. Wait, a flux generator? Yes. Wait, that's magnetical flux. And the capacitor is basically in the Hall effect sensor. Hall effect sensors work. The Flux compensator. Wait, now, yeah, the wires. Where are my jumper wires? Are here, because I cleaned up. What was the pinout of the Allegro? We have the sensing wire. I think sensing, yeah, we can put it in the center. Yeah. Okay. Black. Okay, we have red, black, that's the power. Oh, you don't know the best news. Like I released magic smoke from my solar system. You know, you remember I was talking about that the MPPT controller that wasn't that great. And I switched to my China MPPT controller, and you know what happened? I connected the wires of the solar to the terminals of the load, and the load to the solar. What happened? 100 volts of the solar went into the load and destroyed one of my endpoints at the microinverter. One DC to DC converter is completely broken, and I thought, oh, what was that? Probably the cheap Chinese DC to DC converter blew up, and I connected it to the other DC to DC converter, and it worked. until I heard a pop sound, and one of the capacitors popped, basically released the magic smoke, but it's still working because it has 3 capacitors. It's probably not like 1000 watts anymore, but I'm running it at 250 right now, so it's alright. And I received all the Chinese parts from... Oh yeah, by the way, here it is. You all have been skeptical about that. We can maybe test the switching capabilities of the direct current switches here, not the AC ones that the Big Clive tested. We can just test if they work, also with the load, if you're interested. I don't know. I bought some terminal thingies, but I think they are too big. What else did we get? Yeah, we got all the nice DC to DC converters for high voltage. Some solar connectors. I got a nice big goodie bag. Anyways. Oh, what is shorted? Oh, wagon, that doesn't sound good. Alright, so I wanted to check Allegro linear Hall effect. I don't know which one that was. Maybe the window is still open somewhere. Let me check that. I probably never closed it, but I restarted in my PC in the meantime. No. 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 Oh, I found it. Yes, it's still open in one of my browsers. Here we go. What was the terminal? Center is V out, ground is 3. Okay. So let's ground it. Decode messages. Oh yeah, we could do that. That would be a nice thing to do. Alright, here we go. Pips. We have... Is it 3.3 volts? Wait, what is it? What is it doing? Okay, let's test the magnet. Why is this on? You can turn this off. Wait, I think there is a jumper missing. Yes. Let me take a jumper. This is bent. Come on. Okay, now we get a reading. Oh, you can't see anything. Okay, we have a good reading. I believe, at least, we have a good reading. And let's take a magnet. No, we don't have a reading. Eh? What's the power? Huh? Oh, it's an analog, but why is it only showing Do I have like to supply it with more than that? Damn it. This terminal is broken, so... Okay, let me get a power supply of 12 volts for that. Where do I get one? It's probably only 3.3 volts or something. I don't know what's going on there. Where's my power supplies? I need like a brick or whatever. No. Here we go. Here is one. What is it? 12 volts, alright. That will be. So we have even one cable less to confuse people about that here. Aha! That works. Yes. Okay. You mean like this one? Of course, I have everything. I spent so much money on AliExpress. We can replace it today if you like. I even have like the original screw thing, but opening that, probably the front end is hidden. Yeah. All right, let's do it. Let's test this first. Okay. So magnet. I can't read anything. Oh wait, we're measuring now voltage. Here we go. All right. Nope. They connected right. It's 5 volts. Is the sensor dead? Or what did happen here? No, doesn't work. Did I kill it? Ground is correct. Oh wait! Wrong package. I checked the wrong one. Ground is the second one. Output is third. Okay, sorry. Here. Now we're now we're correct. Okay, that works. That works. You have a good perspective. Let me change the perspective so you will be able to see what's happening. Here, like that. Alright. So, we can do more voltage on the load, 3 watts. Okay, let's put the screw. I need more space here. On top of it, and I hope I don't. We should. Okay, we have one winding. We can't see anything. Let me. Okay. Oh, there is a movement. Okay, I see a movement. I don't know if you were able to see. There is a slight movement. Can we, when we twist it, like turn it around, does it go the other way around? Yes. So this is the test. Okay, so we need measurement. We need more time. All right, so there's some noise going on. 180 millivolts spread. Doesn't do anything. It shows, but then we do horizontal time mode roll. Okay. Do you see that? That's we have. Oh wait, I need a measurement though, not max. I just need a measurement. Yeah, but I can't feed like with load. We would, you know what we can do? We can use our DC switch to switch the load using the signal from signal generated from the scope. That would work. Wait. Wait, now. There's my signal. Come back, signal. Okay, this is with one loop. Should we set up, how much watts do we have? Let's go 10 watts, 10 volts, and current. How do I set the current, the loads? Can I do constant load? Oh wait, that's the setting. I can lower the resistance. I just want one amp that will be 10 watts. Oh, it's so slow. There is no like fast mode, is it? Or do I press a button or something? Does anyone know this? Ten ohms load. Okay. We have, okay, I can do even more. We have now we have now 10 watts of current going on here. And I mean, we're changing the setup quite badly here, but we can measure peak to peak is 190, but this is not like, we need to filter it somehow. Utility cursors. No. Wait, what? Cursors menu? Wait. I want this measurement. Oh, come on, how do I do that? I didn't use it for quite a long time. What do I do here? Okay, here we go. And what is the measurement? Huh? No, this is not good. What? What? Channel points? How does that work? How does that work? Hey Basil. Hey Aditya Pal. Christian, what do I do with the points? Can you do it? Can you spend it? Do you need the rights to do it? Okay, so our nut what is our 200 millivolts is our here we go 100 millivolts, so we get probably what is this, 20 to 30 millivolts per 10 watts. With this is like one winding. Can we remove that? No, I need to unscrew that. Okay, let's test it if we can do without a winding, if we can detect this as well. This would be cool, because then you can just take a thick wire and see like, so let's imagine this is 10 watts. 100 watts would be 10 times, that would be 200 milliamps or something. 200, 300 milliamps, which is really cool already. Okay, let's test only one watt, no winding at all, only the wire going through the screw here, the nut I say. Oh, there is still movement. What? Wait, what happens if I, okay, without the nut, this is our counter. Oh, there is something happening. Just putting it close, there is something happening, but not much. Okay. But this is wild. Look at that. Okay, I will try more windings. Should be higher voltage then. We try 4 windings. Zoom in on scope. Okay, yeah. I think more than 4 won't work. It's quite tight already. Alright, here we go. It's a bad day for measuring current because like we're producing just heat here and it's so hot outside. I'm melting. Between the 2 wires, oh, that could work. Okay, let's go. I zoom in. There. Here. Bam! How about that? That's like, let's move it precisely. Okay, this is around, what is the 200 millivolts peak to peak, so probably, okay, we can see this is like 80 millivolts. That's cool, isn't it? Okay, let's do turn it around. It should go in the different direction, yeah. That's cool. That's amazing, we can measure that. Oh. Okay. So that works. I blow up a gimmicky stuff like on-screen effects, gambling. You have that bot. If you have that bot, annoy the streamer with sound effects, etc. Since some streamers have autograph reward for 100k. Basically just a reward system for active people. Oh, yeah, I have to read into that. That sounds cool. I'm sorry, I didn't know that there is something like that. Alright, so our current measurement nut works. Whoop. 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 That's cool. I think we have a project. We are onto something. Okay, there was a question to put it between the wires. The sensor. Okay, we have here. Now I need to take distance, but here between the wires Okay. I don't see anything happening there. All right. Do we repair my power supply now, or do you have suggestions? What can I measure with Hall effect? Force. What kind of force? Oh, I mean with a magnet you can measure force or what? If you add the magnet and a spring or whatever. A seismic measurement unit. Okay, let's try a washer, but the washers are really Super chat! Oh, Johnny, thank you! What does it say? We need to implement the alerts. Ah! Okay, it says super chat. Nice. Okay, 4 windings, just a washer. Let's see how the washer does. If it's also like almost 80 or whatever. Come on. Oops, what did I press? No! I changed the setting. I changed the setting. Okay, here we go. Okay, let's measure. Okay, we have the same current, also four windings, and now let's measure what that brings. Oh, it's the same. What? That's way easier. What? It's instead of that, you can just take one single washer that's like even crooked. What? That's cool. That's even stronger. Is it stronger? What? That's like 100 millivolts. Amazing. Yeah, look at that. That looks... Crooked washer wins. I suspect like magnetizing. Yes, the polar axis is basically orthogonal to the flat side. So this is inverted. Yeah, that's cool. Washer works even better. Isn't that cool? So instead of buying super expensive measurement stuff, you just buy a Hall effect sensor and use a washer. Or you can probably just take any steel pipe, piece of a steel pipe, or probably just a steel wire, a nail. Wait! Do I have a nail? I just need a steel nail. do I have nails? That's crazy. Okay, let me test something else. No, not expensive. No. Wait. Okay. Hey, foo! Did you miss the fun? We just used the washer to measure current. Okay, it's a little bit understatement because. Okay, how about we use a wrench? Can we use a wrench? Just wrap around the wrench here. Can we see anything happening? Yes. I need to record this. This is crazy. What? You just take a wrench and then oh, what? The old wrap the wire around the nail. Yeah, but that's you create a magnet, but you need I would bend the nail, an old rusty nail. What do we have here? Can I find the nail, please? This will be the best. Now that's a needle. Okay, that's an is it aluminum? No, this is steel. Paper clips out of steel. I have even more washers. Without the wire wrapped around it, do you think it's magnetic? Uh-oh. Oh no, it's magnetized. Shoot. You're right. Interesting. Oh, did we magnetize it now? Damn it. Oh, that's bad. We magnetize it. That's bad. Oh no. Oh no. We need something like a ferrite that's not. Yeah. Oh, we magnetized it now. Okay, let's try a paper clip. A spring. Spring, it doesn't need plastic wrench. Okay, I opened the paper clip. I need not to touch the wires. Okay, it's I want the paper clip to be my coil, to be my electromagnet. I wrapped it around a few times. Here you go, paper clip. Come, paper clip, come. Can't tell if it's an electromagnet or not. Let's turn it around. Yeah, it's doing something. I tested, but we could see something. Maybe we should do the switching thing. Okay, we have the switch. How cheap? This is DC current sensors. I didn't find any for less than $3 or $4. What? Bengismo, what? Don't kill my YouTube video. Wait, current. But why? How do you make? Oh wait. How does that work? How does that work? How does that work? What is that? Huh? Yeah, but 10 amps? Seriously? Yeah, but this is like, I want more. I want 100 amps. Like my solar system has like, there are barely any solar panels that have less than 10 amps. I wouldn't like to put it through there. Oh, alright. Interesting. Wow. Interesting. Alright. Yeah. Then guess what we are doing is pointless here. 100 amps. We can measure 100 amps with our sensor. 100 amps at it will be 8 volts min max. I don't know. Yeah, but shunts, that's hard. I don't want like to interrupt it. I would like basically not to have to mess around with the cables. Especially if you consider now here's my rant. Yeah. Project looked like fun. So, what if you want to measure your system like with a clamp meter, but not interrupt it or put in any other electronics to basically not lose your insurance if your house burns down and you have like messed around with the solar setup then it's not in chip anymore. So probably there are use cases for that. Just using a clamp meter. Wonder if we can put kind of sensor on top of a big PCB trace. Probably you can. Wondering. Oh, but does it work also with DC? What happens if we wrap a wire just around and then $300 amp, $11? Yeah, then I am cheaper. No DC. Yeah, we are cheaper. 300 amps. You can measure that probably with a temperature temperature sensor. Canadian dollars. All right. Oh yeah, then it's only what, like six US dollars. I hope not. US dollars is so bad right now. No, you can't with DC. Yeah, I see the problem that my tools will get magnetized when doing that. Yeah, we wanted to do a setup, so let's do a setup. How about that? I need something where I can pass 1 amp through. Okay, so we want to turn on this off, on and off with we need a common ground. Wait a second. Do I have a wire? Yes, here. Here is my test setup. Okay, I can put this there. This in there. Oh. Yeah, 30 amps sounds sick. Okay, so this is plus. The different screwdriver. I hope I have a bigger one here. Okay, I need a big screwdriver. We can test our new toy here. The DC switch. And wait, this. And this will be this. Okay. Now I need to connect something here. So this is our switch, this is our generator. I need a longer wire here. Oh, this is good. I should not plug it in first and then, okay, plus and minus. And I hope they have like a common ground or something. Should be. How many watts? I produce currently 2000 watts and feed it into my two batteries. One big battery pack and then, okay, here we go. This is a mess. I never tested this module. I hope I don't destroy my scope. Where is the generate wave gen? That's too fast. Okay, wave gen frequency 1 Hertz or something. Oh, waveform. I want square. And I want, okay, it blinks, but why don't we get current flow? Did I do something wrong? Let's lower the frequency. Okay, it takes longer than. Oh. Duty cycle, it just takes a while. Okay. Now we get a duty cycle. Let's measure our paperclip. Can you see it? See everything? So our DC switch is working with the no. Paperclip is magnetized. Okay, that didn't work. Let me test the nut again. Oh wait, the washer was good. Let's test the washer again. Not that the washer was magnetized, but if it magnetizes. So what copper is? What is magnetic when only when it's powered? But I like that the DC switch is working. Okay. Let's test the washer. I can see a change, but it's not a big change. Ah. Can you see that? Wait. Let me auto scale. Ah. Wow, there is a delay in the DC switch or what? Oh no, wait, the delay is probably in the load. But I can see the edges here. Maybe, okay, when I change the position, it changes. What happened to the loads? Doesn't turn on. There you go. Okay. We can see a slight movement. I'm wondering what happens if we use. Oh, look at that. This is nuts. Okay. It was this one. Should we try the other sensor? Henrik! Transformer core. For the material. Yeah, transformer core. But where do I put the sensor there? Let's try the commercial DC sensor. What happens if I just don't use a load? A wire. We would need like a 10 ohm wire for that. Okay, I have no clue what the terminals are of that one. Maybe let me check the other one so I can see that. Ah! Here. Oh, it's almost 10. Yeah, there won't be any PCB layout today. I can't see, I can't tell. Damn it. Okay, we have a part number on that. Our DC switch does the job. I like it, Picasso. There we go. WCS 1. Foo! Transformer strong electromagnet, but it won't get magnetized itself most of the times. Thank you, Foo. What's going on? Alright. People are very generous today. Thank you very much. I will put it in towards my GoFundMe. I will put it in a wait, let me put it on the screen. Where is it? Not dashboard, how do I Ah! Here. I put it on the screen. Where is it? Whetstone bridge? What is a whetstone bridge, Dave? Can you please elaborate? Mini digger. Yeah, but pressure send. What? Temperature of a wire. Okay, let me do impact. Impact is narrow. Here we go. What? Oh wow. This is too thick. How do I... Oh damn it. Here. What I am up to? We just discovered plenty of possibilities to measure current, like a old a washer was the best so far with an Hall effect sensor. Now we will test this part. I just need to check the terminals. So what are the terminals? Tell me. IP current. The out. There is a capacitor towards ground. Oh yeah. VDD, and we need like a capacitor. So here is this is out, this is ground. This is basically the same setup. Here we go. I think it is this way around. Ground was center, VCC, VDD. Oh, is this only unidirectional? Oh no. What is going on? Ah, now it popped back up. Where is it? Probably 2.5. Yeah. Yeah, it's the same setup, peeps. It's the same setup. Oh, shoot. You can't see anything. Here we go. So, new setup. Sensor placed. I will just undo this one. This is our current sensor so far, the best one that we got, and a washer. And we just we need this way around. We just put it through there. Look at that. Okay, that sense is way better. Yeah, I would say this is cool. Oh, that's definitely better. There is some delay to what the load does, strangely. But I don't have a 10 ohm power resistor here. Commercial. But it's still only, what is the peak to peak? 200 millivolts? No, 70. Oh wait, yeah, division is 70 millivolts. It's as sensitive as our. No, wait, we had this with 4 windings. Or 3 windings. It's 3 times better than our washer. Hey Z80. Okay. I think project done. I will need to test. Okay. What is magnetic? What is magnetic but does not what? Wait. I will ask OpenAI here. Go to voice mode. Hello. Oh wait. It's not on loud. Yeah. Okay. Can you hear me?
Yes, I can hear you. How can I help you today?
Okay, I want to build an electromagnet with a core that's not magnetizing.
That sounds interesting. Are you looking to use a specific material for the core? Or do you have any particular requirements for your electromagnet design?
Yes, the electromagnet should, like when current is flowing, we should have a strong magnetic field that I can measure with an Hall effect sensor, but I don't want it to turn into a permanent magnet where no current is flowing.
Got it. For an electromagnet that doesn't retain magnetization, you'll want a core material with low coercivity, meaning it can easily be magnetized and demagnetized. Soft iron or ferrite materials are good options. They allow the magnetic field to form when current flows, but won't retain significant magnetization once the current stops. Does that help?
Really? I thought you can make you can magnetize a rusty nail.
Yes, you can magnetize objects like rusty nails using a strong magnetic field, but those materials tend to have higher coercivity, meaning they can retain some magnetization even after the current stops. For an electromagnet that only has a magnetic field while current is flowing and quickly loses it afterward, materials like soft iron or ferrites are better choices. They won't retain a significant magnetic field once the current stops. Does that make sense?
Yes, but I can't work with ferrite because yeah, you can't get it. You can get it easily, but can we work with that? I don't know. Do you know any others malleable materials where washers or nuts are made from, so I can repurpose those?
Certainly. If you're looking for malleable materials that can be easily sourced and repurposed, you might consider soft iron washers or mild steel nuts and bolts. These materials are commonly available and have relatively low coercivity, which means they can become magnetized easily and lose their magnetization quickly once the current stops. You can use these materials.
What about copper?
Copper Copper is a great conductor and is often used for the windings of electromagnets, but it doesn't work well as a core material for creating a strong magnetic field. Copper is not ferromagnetic, so it doesn't enhance the magnetic field like iron or steel would. For the core of your electromagnet, you typically want a material with high magnetic permeability, like soft iron or mild steel. Copper is excellent for the wire windings, but not for the core if you want a strong, easily demagnetized core.
Okay, what other materials can you suggest that are not as good as mild steel or iron, but still good enough to have some sort of magnetizing effects?
If you're looking for materials that aren't as strong as mild steel or iron, but still have some magnetic properties, you might consider the following. 1. Electrical steel, silicon steel. It has higher magnetic permeability than regular steel and is often used in transformer cores. 2. Aluminum. While not magnetic, aluminum can still be used in some electromagnetic applications due to its conductivity. 3. Nickel. Nickel has moderate magnetic properties and can be used in some applications where moderate magnetization is acceptable. 4. Cobalt. Cobalt is another metal with decent magnetic properties, often used in specialized applications. These materials are not as strong as iron or mild steel, but can still be useful depending on your specific requirements.
Where do I get cobalt from? From cobalt?
Cobalt is typically obtained as a byproduct of nickel and copper mining. It is often sourced from countries like the Democratic Republic of Congo, Canada, Australia, and Russia. If you're looking to acquire cobalt for specific applications, you can find it through specialized metal suppliers, electronics component distributors, or material science companies. Keep in mind that cobalt can be more expensive and harder to source than more common materials like iron or steel.
If I want to go to Congo, what is the best way?
Traveling to the Democratic Republic of Congo, DRC, requires careful planning. Here are a few general steps. 1. Visa. Check visa requirements for your country and apply for a visa in advance. 2. Vaccinations. Ensure you have the necessary vaccinations, including yellow fever. 3. Travel advisory. Check travel advisories and safety information from your government or international organizations. 4. Health and safety. Be aware of health risks and take precautions against diseases like malaria. 5. Local contacts. Arrange local contacts or guides to assist you. Please ensure you research thoroughly and consider safety and legal requirements before traveling.
Can you help me to get a permit for mining cobalt in Congo?
I can't assist with obtaining mining permits or any legal processes. If you're interested in mining activities, it's important to contact the relevant authorities or legal professionals in the Democratic Republic of Congo, who can guide you through the official procedures and ensure compliance with local.
That escalated quickly, didn't it?
I'm here to provide information and support with any questions you have. If there's anything else you'd like to know or discuss, feel free to ask.
Okay, thank you very much for your help, and please don't kill me when you take over the world.
No worries, I'm here to help and make things easier for you. If you have any more questions or need assistance with anything else, just let me know.
Okay, maybe you can give me some tips when Armageddon is here and you take over the control over the planet. How do I survive the best?
I'm here to support you with any questions or information you need. If you have any other topics or things you'd like to talk about, feel free to ask.
Okay, peeps, I thought about it. Ferrite, it's so hard to source. So hard. It didn't say. Okay, so it turns out, peeps, look at that. Yeah, I need the mini digger to get. Oh wait, we need to add them here. We need the mini digger to make a bunker. Look at that! What I found in my shelf. Ferrite. I I can do my own clamp meter with blackjack and hookers. Peeps, look at that. What? Look at this. Should we try that one? That's from Futurama. A meme. Ferret. Oh wait, that's different? Ferret and ferrite? Or do you are you laughing about German spelling Ferrit? Ferritkern in German. Okay, let's measure. Let's use our new tool here. New ferrite core. Okay, this thing works well. Nice, thank you. Okay, thanks, bye. Where's our sensor? Where did I put it? Damn it. Ah! I lost it. Oh, it's on the floor. Here we go. I mined this Hall effect sensor on my floor. Here we go. This, and then we just need, yeah, we can put this back in here. What? Henrik, thank you very much. Amazon has cobalt for sale. Not that wait, cobalt. Let me say, but not here. Cobalt. I only see drills. Let me check eBay. eBay. Oh. Cobalt. Okay. Cobalt Scheibe. Ah. Can you, Henry, can you give me, oh wait, the link. I give you moderator rights again. Here. Can you drop a link? Cobalt. Yeah, but I just want to see what I have to look for. If you can drop the link. Okay, let's test our ferrite. Okay, peeps. Should we try the small? Oh no, I have the magnet to my ferrite core. Stuck to my ferrite core. Okay, here we go. Here's the wire. I will just put it in between. It doesn't stay there. How do I? Yes. Look at that. Do you see that? It's not as strong, but it works. Yes. What do we have? Zoom in. Whoop. Enhance. Here, this is the small core. Just passing the wire through. Okay, that's cool. Let's use the big core here. This one. This is a clamp meter, 100 amps clamp meter. But it's too wide. Oh wow! What? Look at that! I just put it there. What? We made a clamp meter. A billion amps clamp meter. A load cell? What is a load cell? What do you mean? An electric load or what? This thing? Do you mean this one? What do you mean with load cell? Weight sensor. Weight sensor for... Oh, a weight sensor. I don't have one. A piezoelectric? No, I don't think I have one. Let me check. My sensor. D-Messstreifen. No, I don't have that. I'm sure I don't have one. No. Oh. Pips, are you satisfied? Are you satisfied? Ah, right. You know what? I'm really satisfied with the outcome. This is like we can make all sorts of I don't want an intrusive measurement style thingy, but this is really cool. I didn't know that it's so easy, because this one I have to put the wire through, but if you have a solar cable like this one here, nope. I don't want like to open the cable. Yeah, I know. In this one anyways, because this is like a huge core. So this is really cool. This is crazy. Crazy easy. Hey, I'm a boy! You missed all the fun! We are improvising current measurement units. Excavator. Wait, don't tell me someone donated here. No, not yet. Thanks. Not donating. Read the text. If you type this link, read the text. Touch each other. Ah, interesting. Yeah. but only 2, because in that case you need like the gap for the electromagnet thingy. Otherwise you have like only the, how do you measure the flux? It needs to be open on one side. So how it can be improved, let's do a cut. Okay, we have now yeah, I know. Here, I don't know what this one uses internally, but it has to be something like that as well. Oh, it's an iron. Oh, wait. We can see that here. Interesting. Look at that. There is also an opening down there. Interesting. I think what they are doing is there is only metal in this part, and this part are probably 2 Hall effect sensors or something in the clamp meter. So what I see now is what we need is basically, so we have like magnetic field. Why should we? If we have a core, oops. Okay, so what happens here is we have this gap, but the magnetic field is weakened a little bit, and then we have like the magnetic field going like this. And we need this gap for the Hall effect sensor to get this magnetic field measured, the flux. Here's our sensor in between to measure this flux. Oh, interesting. Okay, so the only thing we could use, like we could do to improve that measurement here, I don't know, probably not, because then in a solid core, okay, maybe I tell bullshit, but imagine you have like a drilling here. Now the people that paid attention to thermal dynamics and physics probably know better. Then our flux is going like that. It's following basically the more magnetic material, and there is only a just very weak signal probably going through here, very weak. So the flux is going rather around that hole. File. Yeah, that's what I meant. Okay, so what my suggestion would be, what you say is basically to improve this part here, just filing it down so it's flat again against this part. So we have like filed down one end, so these are touching when this is closed. So that would be one improvement. Cool. But we don't need to do it. It works like, oh, it died. Oh yeah. I think my load is out of power. It has an internal battery and it's off. Off now. Okay, let's turn it off. Now that worked fine. Peeps. I will recharge that one. We don't need that anymore. Yes. What I also thought about is, what about taking washers which have like only an opening, and then we can just rotate them like that. Okay, you see that? The washers are basically like alternating, and you have a wide opening, and then you can basically close it so the washers are still like touching in some places, but I like that. What do you think about that? Probably not good, eh? Path of this lock washers, yeah. Or just 3 washers, or 3 2/3. Rude! Thank you for the follow. Here we go. So imagine we have washers that are like that, and then can be also just 2, and then we have another washer that can rotate, and they are touching in this area, so easy peasy. And we can put a really thick wire through it. A really girthy wire through there. A really girthy wire. On the other side, the wire can have some sort of connectors, whatever, and then we can close that around it, and here is the Hall effect sensor, and then it touches like only the Hall effect sensor from both sides. We can enclose this in a 3D printer or something. Like this one is also girthy. DIY current clamp? Did he do it? Nice. Damn it, everything has been done already. Do I watch it first, or do my take on that? Because if I watch it, I'd probably be spoiled. What works and what not. Obscure, I want like obscure current measurement units. You do you, buddy, alright. Everything's been done. Oh, damn it. Even that has been done already. Alright, I would say, since I still have like to finish an edit of a video, which is only like maybe halfway done. It will be a long night. I will just repair the power supply. We swap the terminal that's broken, and then we call it a day, okay? That will be probably like half an hour still. $15, nice. I bet you can make it in 10. Here is. Look at that. And this ferrite costs probably like €1. All right. $5. I bought this one here. Let's take a look. I think it's does the C5 has an or is it C3? So I bought this little thing. Where is it? C3. Oh, it was $4, but it has already a display. I never powered it on. Maybe let's try powering it on. What does it do? What does it do? What doesn't it do? I hope there is something pre-programmed. No, it's not. Oh yeah, it is. It's probably only a test sketch. Boop. Yeah. C3, does it have an ADC? Is the ADC of the C3 good? OLED, yeah. A small. This is the tiniest OLED ever. You could make probably OLED fingernails from that. Small OLED, yes. Yeah. This is like for some people, cosplay people or whatever. Consider that this OLED, like at least for my nails, it would probably fit underneath a nail or something. Dutch. Here you go, big one. So this is like my thumbnail is even way bigger. It can hide the whole module. No, it can't. But yeah, that's that tiny screen. What is that? What? Return. That's so cool. Really tiny. Let's plug it in. Boop. Boop. Okay. If you're interested, here is my affiliate link. What kind? Op 7. Okay. TTS is really what is this? All right. Does the C3 have a good ADC? Noise rejection? Carl? I didn't watch. I think that the last one that I saw was his sphere rebuild. Oh, is it a 12-bit? Oh, it has a 12-bit ADC. Look at that. 12-bit ADC. Should be good enough to measure some current. There's a cheaper one. It's but it upped in price. I paid only $4 for that. Wait. Huh? No, I don't want like this super sale. AliExpress gets worse and worse. How do I... 190 per piece? 0.42 inch is the screen. Put it on my... I can't even put it on my favorite list. So bad. Combo blast. I don't care about your combo Temu's style stuff. It's probably 2.2 euros. What? Again, fucking combo blast. I don't want this. Where is it? Stop it. Okay. Sorry for cursing, but it's annoying. Off screen. What did you do? Yeah. I click. Okay. I show you what I did. Okay. So, where is it? Huh? I don't want to dox my address. Huh? Alright, here. I tried to get a cheaper deal here, and I click that, and I land in this stupid whatever, but I can't like add to my pics, and this is like this stupid sale whatever thingy. I don't want like... Okay, if I do that, add more, 3 more, but this is 3. What the and now you have to buy other crap like that. Add to my pics. Add 2 more. Why 2 more? Oh wait. Oh wait. I have to check that. Free shipping. 570. Oh no. Need to write that down. Doxed myself. We saw nothing. Alright. Anyways, let's repair a thing. I'll probably need to go up. Whoop. Disassemble everything, turn that off. We can turn off everything that generates heat in here. I will discharge everything. So let me turn it on again. Okay, I hope it's discharged. Then let me grab a proper screwdriver. And we will open this thing. Oh, there's so many screws. Wait. I have tools. Single version, yeah. Oh, I paid, I think, $150 or something for that one. It is really long time ago now, 10 years. I switched, it's too loud, I switched even the fans for ones that are less noisy. And it's still loud. I hate noise. Sorry. Something still. Do I need to take off this thing? No. Looks like. What is it? Where is it? Do I need to completely remove that? Can't remove that screw. It turns. Yeah. Eh? Okay. Just needs some more force. Oh no. It's buried here. Interesting. There is a hidden opening here, right next to it. Yeah, this is hard to get there. Damn it. Oh! Wattwiese. Or Wattwise? Thanks for the follow. How do we open that? Get shocked. Yeah, I don't. Oh, damn it. It's so much work. Can I take this off? And this is even secured. Oh, wait. I could undo this one. Yeah, I discharged. I just turned it on. So there is not much. I turn it on when. Yeah, these are fans that I bought. A rotting bitluni. That would be a stream. This journey. Fun. I can reach it from here. Look, the transformer. This is good. This is a big one. How do I reach that? I might be able to undo it. I might have a small wrench here that fits. Oh, you're right. But you know, there's the cable again. And this one is also glued. There's a lot more going on than you. Okay, maybe we can only undo this one. Ah, there's 2 more screws. Okay, yeah, let's try that. But yeah, no, this is the cables. I don't want to mess around. I already forgot which one I detached. This one here. too many screws. Okay. We have at least a little bit of mess. I just need to reach that part here. This annoys me, so I will undo it a little bit, like that. Can you even see? Yeah, you can see. You can't see anything. And this, oh, they all the same size screws. Okay, so I can mix them. That's alright. So, here we go. This is the board. But it's, I think, is it next to it? Yeah, no, basically the terminals are holding that board in place. That fits! Yeah, destruction of or repair. Oh, no, I bent already a pin. Maybe destruction. This one is glued. Ah! Nice. Here we go. Come on, open. Alright. So, but don't lose the nut. How do I? Oh no. I have to yeah. The issue is that I can't remove it probably without removing all the parts of that one. Phew. And I have to undo everything here to remove the board. The cap is in my way. Lock washer. I want to drop that everywhere. Can you see enough? If I get you closer. Okay, board. There is a washer missing. What? Bastards! There is a washer missing. The other ones have like an extra washer. Wait. Yeah. Or maybe it's not necessary for a ground pin, or what is it? What is it? Anyways. Oh, there are two more. Two more nuts. Oh, this is nuts. How do I reach that? Yeah, very funny. Very funny, Matthias. All right. That isn't that hard to remove. And a big washer here. This is the terminal. Can we get just that part? Where did I prepare it? Here. I guess that won't work. This is completely different. Different style. Let me check. I can't even undo it. Can I? No. And this is like way smaller. This won't fit. No, this won't fit, peeps. What do we do now? Ah, I can't put the board back in because that one has like this plastic thing. It's protruding. I would need to remove the plastic thing or whatever. Let me check if I can remove the plastic thing. Okay. I would need to try to destroy that or something. Can I remove that? Need second pair of pliers. Oh, it's so hot in here. I'm dying. Okay, let me. I will probably destroy this terminal this way. Nah, it's completely enclosed. The only thing that I could try to do is basically destroy this plastic here. We can do it. I don't need the terminals if I never use them. Or just destroy this plastic and I'll try to insert it in the old part. won't have the same performance but the screw or the bolt is continuing inside, so that's good. Oh, it's already mangled, huh? I try to... Oh, that's also a washer, it seems. Damn it. It's too bad that it doesn't completely fit. Can't hear anything. Are you still there? Or did my TTS die for some reason? What? Just came off now? Alright. Small washer. It will fit inside, but the washer is too big. I need a smaller washer now to fit the terminal there. Shoot. It's already a little bit mangled, but okay, let me check if I can get a washer that's newer. Or I'm wondering. Oh, this is the broken one and it's still inside. Look at that. So crazy. Yeah, this won't fit there. It's a different size. All right, we will work with this one. Anyways, let me check if I have a washer that fits. Do you have also a box like that with all the stuff inside, like all the screws and whatever that you never used? Or okay, I need something that fits in here. Smaller. I mean, I could take a lock washer here, like that one. That will fit. Just zip lock. They're all too big, I believe. Just need a small one. I could also use a nut instead, but this will be probably, yeah, it will be too big then. Let me check if I have something here. 3mm, no. No, this washers are also too big. Nope. But I probably need to use a nut anyways, because otherwise, if we counter from the other side, it will just be pulled in, come loose. So we need something actually that's Oh yeah. Needs to sit there. Here like that. Hope that lock nut will work. I'm not convinced. It probably won't come off, but let me at least straighten it a little bit. Okay, I have a bag of, oh, it's closed. Cool. I will get a bag of washers and be back in a second. Okay, I give up. It seems no washer of... I'm back. It seems in this household there is no 3 millimeter washer. There's no such thing. I found every other size, but not 3 millimeters. And I have a second box here. Yeah, but I won't leave it open here. I will just close that chapter with the lock washer. No, household is complete. Alright, and mine will never be complete then. I give up. I have some, but I couldn't find them. I don't know where. 3 millimeters. What the F? Where are they? Maybe I can steal one from one of my thingies here. Unbelievable. Alright, I guess we have to use the improvised lock washer. At least it's stainless steel. I don't know if it's good or not, but it will do the job, I guess. I hope it doesn't spread or something. We should be able to, we need to lock it once. Ah! There won't be pink LEDs, I'm sorry. Sorry, not sorry. I also need to put washers there. Need to put washers there to have it at the same height for the PCB. I hope I don't destroy that. I also should bend back the pin here. This will bend back by itself. Alright. Can you see that still? So this is the new front end. Ah! Oh wait. When I put this washer there, it will probably short with this trace. I need to do a different thing here and use this one. I think this adds to the thickness enough. Ah! Alright. to do the other ones as well. I think one didn't have the washer down there, the ground here. What it is. Ah, this is so annoying. Okay, and then washer, lock. Okay, and nuts. Why do I have extra nuts here? Did they use 2 nuts? I just forgot. No. Where are the extra nuts coming from? Oh, from the terminal that we removed, alright. Everything alright, everything alright. But I mangled the stupid terminal that we just attached so badly. Oh, it opens. Alright. Dropped something and it was plastic. I don't have such a small wrench. All right. It had a broken terminal here, and we replaced it with one that doesn't fit at all. All right. I think we are done here. I just need to reattach the wires. Oh. And the front end. Ah. Oh, I just pressed this bar against the PCB. Okay, this plugs in there. Did I miss anything? Excavator. Repairing. That's a repair, my friends. We will turn it on, and if it blows up, you can laugh at me. Wait. This feels like it's a shorter screw. Were the longer screws for that? No. No. Oh, wait. No, they're all the same. Alright, so let's check wires attached. Terminal looks funny, but better than a broken one. This is the broken one. What's the other part? I think I just dropped my PSU or something, bumped against it and just broke off. This is to this middle top? Yeah, here, you're right. Okay, let's move the wires away so we won't cut them with the case. Come on. Okay. So we don't forget that. It's attached to the frame. I won't use the electrical one because you feel annoyed for the sounds. Oh, it won't go on. Okay, we can leave it like that and we can test it now. There is one screw for grounding. Okay, look at that, it's broken here. Wait, did we break it just now? Did we just break that here? There's a crack in the screen. Will we put it on a screw and crack the screen? Thank you. Okay, let me turn on the power. Oh no! The opening of the terminal is to the side and I don't care at this point anymore. Where's my multimeter? Ah, yeah. Yeah, you're right. Okay, let's do DC. $30. Let's try different voltage. 2 volts. Everything all right. Terminal is working. Functional again. Thank you. Okay, I will pull off the cable before turning it off so it discharges. Yeah, we didn't put it on that because I wouldn't put it on the. It's probably from the same accident that broke the terminal. I don't focus by touching this, I need to touch the screen of the camera. So, is there anything you want to discuss for today's stream? Because we are almost done and I will go back to editing the video and I will see you next week. No Friday stream, sorry. I'm visiting friends. Oh, you know what? What? Terminal. That was good. Terminal damage. It's banned. Do you see that? But I don't care. Probably from our destruction of the plastic thing. Dad jokes. And it's like 50. You know, LED wall projects, I don't know, not planned for the next month. Not in July. LED will also be quite hot in here then. Nice. Done. It looks cranky, but it works. And it's the right color, it's red. Ah. Oh! Basil, tell me about it. What did you find out? Same as 003. All right. By the way, look at the final bodges here. These are the bodges, the final bodges for to make this work. Tiny thin wires, yeah. They're human hair. So pretty, yeah. And it's functional. This is the best part about it. The only thing that doesn't work. Oh, Basil, maybe we can talk about that. Did you try to? No, you don't have access to the serial card or the serial chip, because I wasn't able to configure it so it would work with the internal. So pretty, yeah. So this one has the crystal. On that one, I'm running it off the, and I can maybe show that even. Wait, when I plug this in and my computer dies, what happens if I plug it in while the computer is running? Can somebody tell me? What happens? What will happen? Hot swap, but not in practice. Wait. Wait, not much should happen. Pop Paris? Why? So, let me tell you something. Ooh, let me tell you something. I will plug it in. If I get a blue screen or nowadays black screen, then thank you for watching. Otherwise, we will test it. I can see. Damn it, I can't see. It's too dark down there. Where's my phone? I'm touching the fan. All right, you were right. You were right, people. Oh, you weren't right. It restarted. Are you there? Oh, everything is rebooting here. Restore my pages. Damn it, where is the stupid studio? Sorry, I can't read the chat right now. Ah, sorry. Here we go. Okay. Let me get back into TTS. I wasn't able. Okay. Okay, now I can read you again. What is this huge text here? All right, I'm back. Computer restarted. Bad food. Jody, yeah, I know. Sorry. I'm back now. Yeah, so unfortunately it restarted, but I can now show, Basil, if you're still there. I don't see you anymore. But now I can also record that for my video because I need to show that I wasn't able to configure it properly. And so when I wait, that's Bluetooth. Where is my... Oh, it wasn't recognized. The card isn't recognized. What? I have to restart again? No, please don't tell me. Ah, cold start, cold restart. Damn it. No, it's not there. Oh, damn it. Okay. Yeah, so the problem was, what I wanted to talk about is that I can switch, whenever I switch to internal PLL for the serial chip. Yeah, I might have. I don't know. I have a spare one, I think. How would it kill it? Nah, PC is working fine. Grabber card is working, that's important. Graphics card seems to be also working because we are not at 100% CPU right now by streaming. Yeah, so whenever I switch to internal PLL, even though we have like the clock select connected to reset, it wouldn't work. I can't switch to that mode. It switches automatically to internal PLL. I mean, most of the WCH chips do that. But this way I can't switch to 8 megabits per second, and I'm stuck at 115/200, which is terrible for my ray tracer or ray matcher because yeah, it's the bottleneck is the serial. But you're probably not familiar with the serial chip. Someone else had got that serial chip recently. Oh, here are the parts that I need for my video. Alrighty. So that's it, peeps. I signed off for today. I'm sorry the stream was interrupted. Thank you for all the donations. Thank you for the subs and the likes and Ooh, are you sorry? What? Well, are you sad? What's happening? Thanks for the video. Yeah. I don't know. I probably won't be able to stream on Friday. I would love to. It's over for today. Yes, we had 3 hours of fun. It was really good start today. Thank you very much. Nishai! Yeah, you have to rewatch the stream. The beginning was quite good, like the first hour. Alright everyone. Have a good night. Have a good sleep. I hope you're not too hot like I am. It's like 40 degrees C in here. And I see you next time. Bye bye.